Okay, so 2 days ago you should have taken notes on physical and chemical changes via the Bozeman video posted for you through the agenda and also on WebEx. So now we're going to be talking more about physical changes and chemical changes, but actually what they look like and how you draw those. So first let's talk about a physical change. So with a physical change, remember, no new matter is created. It's the same matter in the same combination, and but the spacing is what can change. So a few questions you can ask yourself: is this physical or is this chemical? One of those questions is, does the identity change? Does the actual identity of that matter change? So the answer for that for a physical change is no. Another question would be, can you reverse this? Can you reverse the change? The answer is also no for physical changes. With physical changes, you can reverse them. I'm sorry. The answer is yes. For physical changes, this is very easy to reverse their changes. If you stick water in the freezer and it freezes, a very easy way to reverse that and make it back into liquid water would be just to melt it. So it's a very easy reversal. And then the last question you can ask yourself, is this a same or new combination? And in a physical change, it should be the same. So the actual combination shouldn't change between the molecules. All right, so what does it look like when we actually draw something like this, like a physical change? I have my Flair pens, markers, grab some colored pencils. You're going to need color for this. All right, so I'm going to start with, we're going to use the example of water. That is a physical change you're very familiar with, especially here in Wisconsin when we get snow, which is a solid form of water. So in its solid form, water is very compact. The molecules are close together. I'm going to start with my blue centers, which is my oxygen. And then I'm going to add 2 red dots to each of these, which is my hydrogen. So that is going to be my solid water. So our chemical formula for water is H2O. And then to show what state it is in, we are going to put a parentheses S. So parentheses S equals solid, parentheses L equals liquid, and parentheses G equals gas. All right, so when solid water begins to melt, it kind of spreads out. The molecules are not so nice and compact and forming nice shapes. They're just kind of gonna be all over the place. So my centers, and then our little hydrogens. So that would be what our liquid water would look like. The chemical formula, again, H2O, and that's a liquid. All right, so now we're going to move on to a chemical change. We can ask ourselves the same set of questions. Does the identity change? The answer to this is yes. When you have a chemical change, the actual identity of the substance will change. Can you reverse the process? No. Chemical changes are not easy to reverse. Let's talk about something like burning. Say you're burning a candle. Once you light that candle and it starts to burn, you can't reverse that process back. You have a burnt candle. It's not like you can bring it back to the state it was before you burnt it. And the last one is same or new combination. This is a new combination. All right, so we are going to talk about iron for this example and when it rusts. So we're going to start with our iron, which we're going to use green for. There's 2 nice atoms of iron there. And our chemical formula for iron, our chemical symbol is Fe. And this is a solid, so we're going to do a little S. And we have our water again. We have the same picture up here. So we know it's a big blue center for our oxygen and our 2 little hydrogens. And in this case, our water is going to be liquid. And our last chemical is going to be oxygen. So we're not going to use pure oxygen because that's not how it exists in nature. We use diatomic oxygen, which is just 2 oxygen molecules covalently bonded together. And that's just how it exists in nature. They like to be friends, and that's a gas. All right, so now we're going to draw out our rust. So we're going to start with our iron. And with rust, we get some hydrogens. We're just going to chemically combine our atoms. So, up here, our water molecule looks the same, it's just in a different arrangement. Down here, this atom, this molecule, is totally different. It doesn't look the same as our previous molecules. So our chemical formula for iron is FeOH3. And remember, we have those parentheses there because this is a polyatomic ion, this OH. And we have 3 of them to balance out the iron. All right. On our back page, I'm going to ask you to summarize the differences between physical and chemical changes in terms of what is happening to the atoms and molecules. So, I have a word bank down here for you. You don't have to use all of those words, but those are important words that we've talked about when we're talking about physical and chemical changes. So up on Google Classroom for you, I do have some examples of a good summary and a bad summary. You can look at those if you need some help writing your summary. And then down here, you're going to be looking at this. You're going to be arranging a table for signs of physical change and the signs of a chemical change. And this can be found on page 81. Or in page 82, which is your lab. Utilize both of those resources to fill out this table. All right, we will see you later. Have a good day.